this digit that Okay, I'm just going to say what I just said. So we divided. We had to add our decimal and our 0 to bring them down. We noticed after just adding 2 zeros that my 3 is repeating. It's repeating the steps over and over and over. I continue to have 2 left over. If I continue to add a 0, it would continue to be 20. I would keep dividing 20 by 6 and I would get another 3. So that 3 is repeating. And my answer will look like this, 126 and 33 hundredths. And when I draw a little bar over this 3 here, this bar means that that digit 3 is repeating. Okay, this is what we call a repeating decimal. Decimals either repeat or they terminate, which means end, or it's like pi and it goes on for infinity and it never ends or repeats.
I like pie. I like pie.
All right, now we're going to look at another example down here. Again, my numbers are smaller. I know that you guys know how to divide, so that's not what we're focusing on right now. We're focusing on types of decimals. Okay, so if I do this problem, 20 goes into 69 3 times, which is 60. After I subtract, I have 9, and then I bring down. 20 goes into 95 4 times, which is 80. And after I subtract, I have 15. Now, what do? I add the decimal, and I pop it to the top. And what else do I add? 0. And now I can bring it down. 20 goes into 150 7 times. It's 140. And I have 10. I still have a remainder, so what do I have to add? A 0 to bring down. And how many times does 20 go into 100? 5. Which is exactly 100. So my quotient is 34 and 75 hundredths. This is what we call a terminating decimal because it stops, it ends. If something terminates, it ends. It is over. Okay, now we don't know what this one is yet. We have an example of a terminating. We have an example of a repeating. Now we're going to do this one and see what it gives us. Okay, 11 goes into 6 no times, but it goes into 63 5 times. Because 11 times 5 is 55. I subtract and I have 8 left over. Bring down. 11 goes into 81 how many times?
7 times.
7 times. 11 times 7 is 77. Subtract, and I have 4 left over. Bring down. 11 goes into 41 3 times. What is 11 times 3, everybody? 33. This time I have 8 left over, and I am stuck because I have a remainder, but I know now that it keeps going. All I have to do is add a decimal, pop it to the top, and add a 0 to bring down. So 11 goes into 80 7 times, which is 77. I have 3 left over. Add another 0. How many times can 11 go into 30?
2 times.
2 times. 11 times 2 is 22. Subtract. Bring down. 11 divides into 80 how many times? 7 times, which is 77.
I'm out of room. I'm sick of
And I have 3 left over. If I kept going, because I could, what are you going to notice?
You're the biggest piece of paper. We keep going forever.
What's special about this number up here?
Nothing. It doesn't stop.
It doesn't stop.
It's repeating.
It's repeating. Did y'all notice that?
7 2 7
If
2 7
If I were to have added another 0 to bring down, it's going to be 30 again, and it's going to be 2 again.
I don't want to do that.
Okay? So it's repeating the 7. Listen. It's repeating the 7 and the 2. So what I'm going to do this time, I'm going to write my answer so that it's like this. 573.72. Because the 72 is repeating. It's not just one digit this time, it's 2 digits that are repeating in the same pattern. So how do I draw my bar this time to show that 2 digits are repeating? What do you think I would do? Draw it over both, exactly. This shows that it's 72, 72, 72, 72, 72, 72 forever and ever and ever. Okay? This is called a repeating decimal. Okay. So today I told you guys that we are continuing with long division today, but we are going to be focusing on our remainders. So long division is the same, steps are the same, divide, multiply, subtract, bring down, repeat. Okay, that all stays the same. However, instead of writing R, whatever your remainder is left over, we're going to now write that remainder as either a mixed number or as a decimal. So that's what you're going to see today. Basically, in 5th grade, you have to understand that numbers don't just end with the remainder. It's an actual number. Like I said earlier, if you plug it into a calculator, it's going to be a decimal, and it's going to continue on. So I'm going to show you how you do that mathematically today. Okay, to find, oh, I want a different color, hold on. To find the decimal, in the quotient, extend the dividend by adding zeros. So when I'm talking about quotient or dividend or things like that, you need to know what is what. We've done this before, but we're going to do it again. So up here, this is where my quotient is. This is my answer to a division problem. Inside the division box is what we call the dividend, and then out here we have the divisor. So if I want to continue dividing, if I get down to the bottom and I have a remainder, I'm just going to add a decimal and a 0. And then you see this little arrow here, that means pop that decimal to the top, pop it to the top. So now I have another digit that I can bring down to add next to what I have left over after the subtraction part, and I can continue my division steps. Okay, you can add as many zeros as you want. Today, what we're going to do is we're going to be focusing just to the thousandths place. That way we can round it to the hundredths. Okay, and you're going to see a couple of examples in our next lesson where we have different types of decimals. They're called terminating and repeating. Okay, the first thing we're going to do is we're going to learn how to write a remainder as a mixed number. So we're going to hold off on the decimals for a minute, and we're going to focus on mixed number remainders. Step 1, to write your remainder as a mixed number, you follow the steps for division. So you divide just like normal. Then step 2, your quotient becomes the whole number. So remember, the parts of a mixed number, you have a whole number and then you have a fraction. That's what makes up a mixed number. So the quotient is your whole number. Remainder is the numerator. And your divisor is the denominator. So you're going to see how this pieces together here in just a second. All right, so you see that we have this problem here. We already know how to divide the divisor into the dividend. So we're going to follow our normal steps for division. Okay, so the first step is to divide, multiply, then subtract, then bring down, and then we check and repeat. Okay, So 43, I have to ask myself, 43 cannot go into 8, so I have a little 0 the hero up here, or placeholder. But 43 can go into 83 one time. What is the multiply step? 43 times 1. 43. Now I move to the subtraction step. I subtract that, and I'm left with 40. Move on to my bring down step, and I bring down the next digit, which is 4. And I divide again. So 43 into 404, I'm going to save us some time. It is 9. We already know how to divide, so I'm not expecting you to do that at this moment. 43 times 9 is 387. That's the multiply part. Now I do the subtraction part. So when I subtract, I have 17 left over. I still have another digit I can bring down, so I bring down the 5, and that makes it 175 divided by 43. 43 goes into 175 4 times, which is 172. And after I subtract, I have 3. Now, normally I would have written remainder 3. But what I'm going to do is I'm going to use my quotient up here, and I'm going to use my remainder down here, and my divisor to put together a mixed number, okay? So, there we go. This number right here, this becomes your numerator. So do you see how there's a little arrow up here, and I've already got it started for you? You have your whole number out here, which is your quotient. I've already brought the divisor as my denominator. My remainder becomes my numerator. So my final answer will look like this: 194 and 3/43. That is how you write your answer with a mixed number remainder. So literally all you have to remember is just pull your remainder up, put it as your numerator. Your denominator will always be your divisor, always. Okay? Okay, that's how you write it as a mixed number. You have these notes, so you'll be able to go back and look at it and see. Okay, we're going to be practicing this today and tomorrow, or Monday, not tomorrow. You won't be here, and neither will I. But Monday we'll continue practicing with it too. All right, so now let's look at decimals. This is where we add, I call them the BFFs, 0 and decimal. You can't add one without the other. They're like two peas in a pod. If you add the decimal, you have to add the 0, okay? So we're going to divide again, just like normal. So 43 goes into 83 once, which is 43. Subtract, I have 40 left over, bring down. 43 goes into 404 9 times, which we said was 387 earlier. Subtract, I have 17 left over, bring down. 43 goes into 175 4 times. I know I'm going fast, but we literally just did this one. So we're just repeating what we just did, which is 172, and I have 3 left over. Okay, now this is where it changes. I don't have another digit to bring down, so I have to add a decimal and pop it to the top. Then I add decimal's BFF, which is 0, and bring it down. And I keep dividing. 43 goes into 30. It can't. So I've got to put a 0 up here. Remember, we talked about that yesterday being a really common mistake. We forget to write that 0 at the top. It's super important. Okay, 43 times 0 is 0. So if I subtract 0 from 30, I still have 30, and I still need to add another 0 to bring down. And now it's 300 divided by 43. And 43 goes into 300 6 times. Y'all were close. Which is 258. When I subtract, it's 42. And if I want to round to the hundredths place, I need one more digit to put after my 6 here. So I've got to add another 0 to bring down. The most zeros I'm expecting you to add would be 3 at the most.
I ran out
Okay. 43 goes into 420 9 times, and then we just stop. We don't have to do anything else because now I have 3 digits. So now I'm going to come down to this part where I round it. And remember my rounding rules. Okay, my answer was 194 and 69 thousandths. It was my quotient. It's what I had up here. That was my answer.
It makes a little bit of sense.
Okay. Now, hold on. Did it stop or did we just stop dividing? We just stopped because you only need to have 3 numbers after your decimal. If we're rounding to the hundredths place, which is as far as I want you to go, that's where you would stop. Okay. So here's all of my work. And this is what I ended up with. Now I want to round this so that I can have my answer rounded to the hundredths place. So I use my judge, which is 9. 9 is bigger than 5. So what happens to the digit that I'm rounding? It goes up. So my answer is going to be 194.07 is what I would write as my final answer.
Oh, I get it now. Yeah, I get it. How did you get that? Okay. Wait.
From dividing. It's all right here.
So if you're down to the thousands and it goes to the hundreds, what if you're down to 10,000? Where did you get?
Say that again, Raleigh.
So if you round to the thousands, you'll go down to the hundreds. So if you're rounding to the 10,000, you'll go down to the thousands. Say you have 4.
Yes, exactly. Yeah. Okay, Liam, what's your question? So the reason that you add zeros here is because we talked about this with decimals. You could have like 1,000 zeros after a decimal. It does not change the value of the number before the decimal. It changes how you read it. Like right now, this would be like 8,345 and like, well, you wouldn't say 0 thousandths. That would sound weird. But basically, I could put 100 zeros after this decimal and it's still the same number. So zeros, you could add as many zeros as you wanted, so you could keep dividing and dividing and dividing and dividing if you wanted to. Okay, zeros do not change this number here at all. All it does, it allows you to continue dividing to get an exact number. Okay, let's look at different types of